Welcome to Chemistry World. Today we discuss about chapter 4, metals and non-metals. In your previous class, grade 7, you learned about something about metals. Or you learned about what are the different types of materials existing around you and their states also. You learned different natural processes like rusting, etc. In this chapter, we'll go in depth of properties of metal and non-metal and how they are interacted with the different substances available in nature. If you observe these diagrams on the board and if you able to guess what type of materials are used to make these type of objects. Yes, you are correct. In these objects, you can see some metals inside. For example, jewelry. So what type of metal used for jewelry? Yes, either we can use gold, silver. This is what bucket. Of course, today you are seeing the buckets of plastic material. But if you see the ancient time, the olden time, then the people used to use metal buckets, especially iron. You see this one, axe. And if you see the axe, okay, see this part. This part is also made of a metal called iron. And what is this part of knife? This is also made of different metals. Okay, here also you can take iron, a different type of iron. So if you see all these objects, in all these objects, iron, gold, silver are involved, and all these are nothing but metals. So in this chapter, our point of discussion is metals only. Now guess or think about some more objects where metals are involved. Now you think and tell me that whether all these metals have any similarity between them. Do all these metals shine? Or which metal is harder, which metal is soft? So to answer these questions, we should understand this chapter. So let me tell you about different properties of metals. Alright, now if you see the properties of metal, basically the properties are two types, physical properties and chemical properties. Physical properties means these properties we are able to see, we are able to observe. And then chemical property is going to discuss. So in the physical property, let me tell you the first property is lustrous. L-U-S-T-R-O-U-S, lustrous property. What is meant by lustrous property? Means the materials which can shine are called lustrous materials. Generally, metals shine. Take the gold jewelry, is it shine or not? Yes, it is shine. Take a silver jewelry, is it shine or not? Yes, it is shine. So, lustrous is the common property for the metal, or it is a property to identify the metal, whether it is shining or not. So, generally all metals shines, but there is a caution. Which are shining cannot be a metal. For example, take mirror. Mirror shines. But could you say that mirror is a metal here? No. So, my point is that metals have lustrous property where metals can shine. But the materials which are shining are all not metals. Now, you have to check that how many metals are shining. I'll give some examples to you. Now find out by yourself or observe them around you and observe that which metal having lustrous property. Iron, copper, aluminium, silver, gold, etc. Try it. Now the second physical property of metal, sonority. What is meant by sonority? Understand carefully. Suppose I'm carrying some like 20 to 30 iron nails in my hand, and mistakenly it fall down on the floor. Then what happened? You will hear some type of sound, some ringing type of sound. Generally, any like iron metal, or you can say aluminium, copper metals, when they fall on the ground, you can hear some sound. And that hearing of sound is called sonority. Metals peculiarly have this property. That's the metals are used for bells in the schools also. Why don't the schools use the wooden bell? Because wood doesn't have this property. So sonority is another special property for the materials with which you can find out that it is metal. The next property, malleability. What is meant by malleability? You know, when you see the metals like iron, copper, aluminum, silver, you will find them in different shapes and sizes also. How it is possible? Sometimes you can find the iron in cylindrical shape. Sometimes you can find the iron in spear shape. Sometimes in rectangular shape, triangle shapes. All these type of shapes are possible because of this another property called malleability of the metal. Malleability means the metals can be stretched and molded into different shapes. So with this property, we can understand that all the metals can be flattened into thin sheets. Suppose if you go to a person who is making different types of shapes using metals, and if you observe it, suppose you want to make a shape using iron material, and what you do, he will heat the iron material. When it gets to high temperature, then he heat on the iron material and mold them into different shapes. So all this is possible because of malleability. The next property, physical property of metal is ductility. Ductility is another property to identify the metal is metal. Have you ever seen the copper wires or aluminum wires, iron wires, brass wires? Yes, you have seen many times. In your house, if you see the electrification of your house, all the electric wires which are insulated with the plastic material. So inside you can see the copper wires. So some metals have the ability to stretch to longer in size and make them wires, and that property is called ductility. Generally all the metals have this property, but very popular and very demanding metals are copper, aluminum, brass, iron, etc. Next property, electrical conductivity. Or electric conductivity. What this property means? The property says that the metals have ability, or metals can allow the current, or metals can allow the flow of charges through it, so that current can be produced at different electric appliances. Generally, if you see the electrification in your house, as we discussed earlier, in the electrification they will use all metals only, like copper wire. If you want to connect different electric components together, you have to use copper wires only, which are insulated by some plastic materials. Let me give a small example to you. Suppose there is an electric bulb, electric lamp. Now this is connected to this has to be connected to a cell. Say this is 1.5 volts cell. It should be connected to cell so that the bulb has to glow. Then what we do? You don't connect this bulb cell using a normal thread. It's not possible. Then you take a wire, what we say electric wire. Using the wire, you connect to the cell. automatically current flows and bulb glows. So this wire is made of metal, and this wire allows the current, and this property of allowing current is called electrical conductivity. And all metals have electrical conductivity. You can use copper, you can use iron, but generally we use copper for the electric wires and connectivity. Now I'll give some more examples to you. Try and find out whether they have electrical conductivity or not. Iron, copper, aluminium, silver, brass, sulfur, cotton, iodine. Check. Now you get a confusion. How do I check electrical conductivity using sulfur? Sulfur is in powder state. Now how can you do? A small idea I'll give you. Take a plastic straw and fill the straw with sulfur powder and keep the straw between the two parts like cell and bulb, and try whether the conductivity is happening or not. So metals having electric conductivity, and the metals are called conductors. Here one point I keep on saying that electrical wires are insulated by plastic material. Why it is so? Because as the current is passing through metallic wires, and when you touch directly the metallic wires, there is a possibility of electric shock. So to protect you from the electric shock, it should be insulated. So we have to use insulating materials, and we have many types of insulating materials like plastic, I already told you, cotton, wood, many you have, but generally we use plastic because it is easy to reshape them. So next physical property is heat conductivity. Heat conductivity. What is meant by that? See, take a spirit lamp. Okay, and the flame is coming like this, and take a iron rod and put the attach the iron rod to a stand like this. Now keep a small metallic pins, like L pins we say, like this, small pins using wax so that you can attach. So pin 1, pin 2, pin 3. Now as soon as the iron rod starts heating, if you observe carefully, what happens? Because of course the pins will leave the iron rod and fall on the ground. You understand that? Second observation, which pin falls first? Yes, you are correct. The pin number 1 falls first, and then 2, and then 3. Why it is so? Because metals having heat conductivity, they can easily allow the heat flow. So when the iron rod is heated from one side, inside the iron rod, the atoms gets vibrated, and they will allow the heat to flow from one end to the other end. As the heat is flowing in this direction, so first of all, the heat make the wax to melt. Therefore, the pin 1 falls, and similarly pin 2 and pin 3. So that small demonstration explaining that yes, heat can flow from one end to the other end, and which direction heat is flowing, in that direction only the temperature change or any pin falling can be observed. And heat conductivity not only for iron rod, it is for all metals. Take another example of kitchen utensils. Nowadays, if you want to fry, if you take a bowl type of utensil, bottom of the utensil, it is coated with copper. You have two types of utensils available in the market, but many families will opt for the utensils which have copper coating bottom side. Why it is so? Because copper is a good conductor of heat. So it quickly heat the utensil so that the food would be cooked in faster manner.